Hello class, today's video is about first part of nonlinear kinetics. Although Jordan did a very good job in explaining these first two problems, but I'll go over again and finish the entire assignment. First, you have to remember that for this problem set we need these three equations, especially these three equations of kinetics, various forms of this equation. Now excuse me, first, as I have mentioned in the class, what we have to do, we have to make a table of R against CSS. These are all CSS. So R versus CSS, and this is R is by each 12 hour, 85, 190, 350. So these are per 12 hour, per 12 hour, 12 hour. I am not changing anything here. CSS is 85, 190, sorry, 85, 190 and 350, and then you have to come up with another column which is R over CSS. R over CSS will give you 37.11, 27.30 and 11.25. As I have mentioned in the class, we have to use that equation or the linear form of that equation. Sorry, it is not responding. Okay, again I'm back. This computer today is acting funny. So R over CSS, you have 37.11, 27.30 and then 11.25. As I have mentioned, you have to use that equation. Is nonlinear kinetics here. We have to go back to that equation. Let's clean it a little bit. This is the equation. Here this is the linear form of the equation. So for this reason we have to first we have to find this, and R is already given. Now let's go back to the assignment, and you plot like this. Here it is your R by CSS and then R. And then you should get a straight line like this. It is going to be a straight line like this, and you will have a trend line is y is equal to negative 10.219x plus 466.1. So you know that Km, based on that equation, your Km is going to be 10.22 or 10.2 milligram per liter, and your Vmax is going to be 466.1 milligram per 12 hour, because I did not I didn't change the hour as Jordan did. So here, and then you should have a Vmax of think it is 38.8 milligram per hour. We just divide this number, we just divide this number with 12. So this is how you calculate your Vmax and Km. Once you know the Vmax and Km, we have to play with this value a little more. Let's see. So we now know we have a Vmax. We have a Vmax is equal to 38.8 milligram per hour. Your Km is 10.2 milligram per liter. So now we have to calculate time to reach 10% of steady state and T90%, which is TSS, and it is asking for, it is in days. After the dose of 85 milligram every 12 hours, you have to assume volume of distribution 89 milligram and no drug is left prior to administration of the dose. I have not covered this equation yet in the class, but I am going to show you which of this equation. This is the equation we have to use. This is the equation we have to use to calculate T90%. As you can see here in this equation, is we have R, I think it is 85. We know Vmax, we have just calculated, and we know Km, we just calculated. We also know, and V is given here. So now if you go back, let's write down this equation. Let's write this equation is T90% is equal to Km times V divided by Vmax minus R whole square, 2.3 V max minus 0.R. This is the same equation. If you go back to here, it's the same equation. Vmax, I don't know why it is here like this equation. Let me check back. Sorry, there was the equation. This equation is wrong here. I put mistakenly negative, so there will be no negative here. The equation is going to be the way I have written here. I will make this correction. 2.3 Vmax minus 0.9 R. 0.9R. So we already know our Km. One change we have to make. You see that everything they are asking for in days, but our Vmax is in hour. So this needs to be changed also, and here the dose is given every 12 hours, so that's we have to change. So first thing what we're going to change is Vmax is whatever it says is we got 46.1 per 12 hour, which is going to be 932 point per day. This would be your Vmax. Or if you use this one, in this case, if you use this one, it would be 38.8 per hour. So in that case, you have to multiply with 24. So, but in either case, it is going to be Vmax. Vmax per day would be 932.2, and your dosing rate is, the dosing rate is given R. That it is asking is given 85 milligram per 12 hour. Per 12 hour, this needs to be 12 hour, and is equal to 170 milligram per day. So these two changes we have to make, because this T90% is asking for asking the value in days. T90% has to be in days. So we know what is Bmax, we know what is R, and now we have to put together everything. T90% would be km. We also know this km, which is this unit doesn't change. 10.2 times V. Where is that V? See here. This is the V. So we put 89 divided by 932.2 minus 170 square times 2.3 times 932.2 minus 0.9 times 170. Remember this, it's clear here. 2.3 V max minus 0.9 times in the equation is R. So always these numbers are part of the equation. So do not eliminate that numbers when you are working with this equation. So your T90% would be, if you work things out here, it would be 3.11 days, not per day, because it is total time. So again, let me go back to my note. This is an error. I will take care of it. Otherwise everything looks good. This is an error too. So this is how you calculate T90% using your Vmax and K. Now you have to calculate. Here is the time to reach 90% after dose of 350 milligram every 12 hours. And volume distribution is same. So I am not going to do it again in this case, because you follow the exact rules. This is nothing but another problem changing the number. Just I will briefly show you what's going on. Here again you have to use this for this problem number 4. Let's clean up a little bit. It's problem number 4 is same as number 3. You have to use this equation, T90% and Km V divided by Vmax minus R whole square then 0.3 Vmax, 0.2 Gmax minus 0.9 R. This is the same equation. Only thing is different here. Our R is equal to what is 350, which is 700 per day. Otherwise it is going to be the same, and answer here in this case is going to be your T90% is going to be, I think it is 25.49 days. So this is same problem as the 3 and 4 are very similar. Is the volume distribution, this volume distribution is here. Okay, now we'll use different equation for 5 and 6. Let's go back to 5 and 6. CSS, if you calculate CSS, if 230 milligram of the drug is administered every 12 hours. To calculate CSS, we have to go back to that equation sheet. Yes. Here, this is your equation sheet. So here you have your CSS. We know Km, we know Vmax, we know R, so we should be able to calculate CSS. So here, this is the equation. This is the equation CSS KMR divided by Vmax minus R. So only thing changes here. Your R is kinetic administration every 12 hours. So R would be 230 milligram per hour per 12 hours. That means 460 milligram per day. This is your dosing, right? So and also you know your Km already you know is 10.2 milligram per liter. Your Vmax you already know, which is 932.2 milligram per day. So you put this data here, 10.2 times 460 is R. Vmax is 932.2 minus 460. So this should give you an answer of, is 9.93 milligram per liter. So this is your CSS. So this for CSS you use this equation, and you know R, you have to manipulate a little bit, you know already Km and Vmax. So now in the next question, question number 6 is asking dose. Now we have to calculate dose to be administered every 12 hours if the desired CSS is 18 milligram. So that means it is asking for dosing rate. We are going to calculate R. We are going to calculate R is equal to dose to be administered. We are going to calculate R is equal to 466. Sorry, let's do the equation first. R is equal to, we know that Vmax times CSS divided by Km plus CSS. So this is the equation. I think let's go back. is, no, this is the equation sheet here. This is the equation, this is the equation. So now you go back to that assignment. If this is your equation, you know what is Vmax, and in this case we have to use here it is, everything is 12 hour, so we can use the Vmax of 12 hour. We can use Vmax for every 12 hour, which is 466.1 times CSS is this 80. So CSS is 18, drug is administered every 12 hours, so that's why we are using Vmax of every 12 hour. And then Km we already know, 10.2 plus 18, and this should give you an answer of 297.5 milligram. So this would be your dose. You have to administer every 12 hour if you want to achieve CSS of 18 milligram. Now there is a conceptual question. What is going to happen if the therapeutic concentration goes up? You see here, the metabolism in the linear or non-linear. So this is a concept question. Do you remember what is your Km? Our Km was, let's go back, Km was 10.2 milligram per liter. So what happens in case of when drug concentration goes, the therapeutic is above Km? So you see here, bad drawer here. If you remember this, so your Km, you can say this is here. So you Km, you found Km which is 10.2 milligram per liter, but if the plasma concentration goes up, that means it is above Km, which is here around here, 11 to 24 milligrams. So for this reason, answer is going to be non-linear. Okay. So here again, I did not do as good job as Jordan did. So, but she has good control over English. She could be a host of radio host. Let's see. First, you have to do this plot. Once you know the plot, you have to calculate Vmax. Always look into the unit. This unit is asking for Vmax in milligram per hour, so you have to calculate that. And for this one, for this to use this equation, which I messed up in my note, T 90% is equal to Km times V, Vmax minus R whole square, then 2.3 Vmax minus 0.9 R. This is your T90%. For to calculate CSS, this equation is easy. Here you have to calculate CSS is equal to KMR divided by Vmax minus R for CSS. And here you will calculate dose. R is going to be dosing rate. R is equal to Vmax times CSS divided by Km plus CSS. And here you will just use your brain a little bit and you answer, because this concentration is above Km. So when things goes up, therapeutic concentration goes above Km, it is not going to follow linear current, it is going to follow non-linear currents. And sorry for many interruptions, my computer was acting funny today. I will post the remaining part 2 in a little bit. Thank you.